don't have like access to my touch screen, my tablet here on our session, so it'll be hard for me to do drawing and things on OneNote. You don't either. But if you have a notebook or a laptop that gives you a touchscreen capability or some sort of tablet, you know, you could come back and make your OneNote notes much more entertaining and interesting and informative, because you could highlight things a lot easier than we can with the mouse. So I'll struggle, of course, trying to do that with the mouse, but just remember, it'll be a lot easier with some sort of touch input. So I'm going to talk about arrays here in my notes. And the first thing that I want is to put in a heading, and I'm going to try to zoom in a little bit. Zoom in. And with OneNote, it always goes crazy and moves around, so every time I zoom in, I'll have to rearrange. So I'm going to start with item I. And of course, the great thing about OneNote is after I get started with my outline, it'll notice that's what I'm doing, and it'll keep going for me. So I said this very first heading is something that I'm going to use as an outline point in my notes. I'm going to say this is array basics. So why do we have arrays? It allows us to track multiple occurrences, right? So we can have 15 names inside of an array or 15 integers inside of an array, but we're going to have multiple occurrences of an item. That's why we have arrays. So it's better than us assigning a name for each occurrence, right? Because we could say item 1, item 2, item 3, item 4, item 5, item 6, and we could be forever doing that, but our program code would be very inefficient.
Did your screen freeze?
Nope, it's just sitting there. So what else do you want to say about arrays in basic things? What?
Talk about parallel and multi-dimensional arrays.
We can do that. Do you want to put that in our array basics section? What should we say in array basics? Maybe, yes.
Whether you can set an array length or not, like what the array length is.
Well, let's add another section because you guys are on it. Let's talk about declaring our array. So again, just like creating a class in C#, if we get our thoughts organized as to what they are, and we follow along with the textbook here, is what I'm doing in this PDF to organize, then maybe it'll be a little bit easier to get a handle on. So when we declare an array, we have two parts, right? So let's say, first of all, trying to read this here. We use the new keyword to instantiate it, and that is to allocate the array in memory. And we must declare the array as a certain data type. So let's put an example. Int my int array. That would be a declaration. I'm going to try to get that to be lowercase. Declares an array. Then if we say int my int array equals new int 35, and I'll try to get that I to be lowercase, that declares, instantiates the array. So we've got to declare it and instantiate it. Now, whenever we start putting code in our notes, it starts getting really ugly, doesn't it? It's so complicated, we have to fight really hard with OneNote to do it. So one thing we might want to do is copy in some of our code from our examples. Let's continue on here before we do that, though. The other type of array declaration that we saw was where we could say int curly braces my int array equals, and then within curly braces, we could do the values, right? So this declares and instantiates. Can you think of any other types of declarations that we've run across? Because it can definitely be confusing as we look at the code, because we do have a lot of different options here just to declare an array. Looks pretty good. Those are the main things that we've seen. We've seen that we have our array must be declared as a certain data type. We give it a name, and then we have its size if necessary. So we could use this highlighter tool, and I think that I'll highlight my declaration here. Oh, come on. There it is. My data type. All the different places it is. So this type of syntax here, this middle one, is the most commonly used. And it can also be the most confusing, right? Because you've got that int keyword in there twice. So it seems confusing, but it's just like whenever we create a new instance of any other class, we always follow the class name after the new keyword. Now, we've also seen that our brackets matter. So here, if I highlight those, I can make this into a really colorful mess. But if you were to pull some code right now that had Xamarin code that created apps for iOS and Android, you'd be surprised that a lot of what you'd see in that code would be array declarations and manipulating arrays, and you'd be able to understand a lot of that code if you really focus in on where those names are, where the data types are, and where our square brackets are that are indicating the size of the array or that it is an array. So let's use another color to highlight our names of our arrays. I'll do a muted orange here. Let's see if I can see through that or not. What I want is this part, not that, you silly thing. I want this. Because our array name, we made the same in all of these examples. But again, when I'm looking at C# code, sometimes all these different pieces of the syntax can run together. And so it's good if I can separate it out and find those things that matter. Perfect. So some array things that we need to worry about a little bit more. Let's go back to our array basics. We have an index, and that specifies the location within an array. It's always an integer, right? We can't have any decimal places in our index. We always place the index within our square brackets. So sometimes that index might be a number value that we have in our square brackets. It might be a variable. It could also be called a subscript. a subscripted value. So we'll see that often in different kinds of documentation. Now, while we're talking about our index, one of the things that you guys kind of mentioned was that the array has a defined length, right? And we can't exceed that. Now, as you guys this semester have did that assignment for the class scores, saw some amazing stuff. And some people found an array.resize method, which was just a really great way to handle the problem, but it might not be the most efficient way to handle the problem. So we always have to be balancing, you know, efficiency with convenience in our code. Let's put that down in our array basics. An array is allocated contiguously in memory. I knew I was going to have to spell check that one. Contiguously, it found it for me. Good job. So that means that it's going to take up all that space in memory, element to element to element, side by side. No breaks. Now, we had a lot of pictures in the PowerPoint presentation about arrays. So that's a place that you could go if you wanted some visuals. You also could just bring up Google or any search engine of your choosing and search for array, and then let's look at some images. And find an image that you like, that's meaningful to you, to copy and paste into your notes, something that's going to be a memory jogger for you when you look at it. I see lots of really good pictures. I'll get one of these ones off the top here. Now again, if I was going to put that in a PowerPoint or something, I would make sure that, I just wiped everything out, I would make sure that it wasn't copyright protected, but since I'm just going to put it in my notes, let's see if I can find it. There it is. So my cute little array image that reminds me that each of those array entries are side by side in memory. They each have an index and then some sort of value within the array, their data. Now, another thing that they mention in the textbook is that when we use the new keyword, we must declare the number of elements at that time. And this is sometimes called the mentioning the array. Now, I try to do some code chatter when we're up here coding together, and I'll try to say things like that, like keywords and things, but there's lots of times that you just have to go through some sort of reading material or resource to get a lot of terms, and sometimes you can go through different resources and find different terms. That's a great thing about programming. It's always exciting. Now, when we declare and instantiate an array with our values here, like this very last item, something to add to our notes is that is referred to as using array initializers. Those are those values that we supplied it. This is also called compile time. initialization. Now, how do we access our array? This is one of those things where we might be better off looking at some actual code, but let's put this in our notes. I'm going to back up all the way to our highest level and put in a new entry for array access. And we just specify the element to be accessed. We use our index. And we specify the name of the array. So we're going to have something like array name index. And that's how we access that element. So if we wanted to set that element to something, to a new value, it would be before the equals, right? To the left of the equal sign. If we want to retrieve the element's value, it would be after the equal sign in our assignment statement. Let's add a couple of more things up to here when we were talking about our index. Our index always starts at 0. If you notice, we could write a chapter about indexes, huh? Just all the different things that we want to say about them. So we have a lot of different information. I'm getting some errors on our wonderful PDF here. All right. Now, another thing that we saw was the array class. So I'm going to come down here after our array access and add a whole new level. The array class is a C# class that defines arrays. Any array we create inherits from the C# class. That means that we can use all of the class's methods that are part of C# for our array. So if we look at the array class, we can see that the array class has all sorts of different methods that are available to us. Many properties and methods. Now, if you look at that PDF document, I'm going to slide it over here, don't worry. I'm looking at chapter 7, that chapter that talked about arrays, and they have kind of some brown pages where they talk about a lot of these different array methods. We used some in our application that we created, so we've seen quite a few of them, but there's always lots more. Now, these are listed in the textbook in that PDF document, but they're also available on Microsoft's website, of course, in docs.microsoft.com, where they talk about arrays. They'll have a whole section about array methods, and it'll have example code and different things for you to use, so you can find them that way. You also could find array methods on all sorts of different C# helpful websites. So whatever you want to, whatever site you like, you'll get used to certain ones that you like to use. C# pearls, different things that are good. So we saw a few of the different properties and methods. Let's list some. One would be sort, reverse, clear. We could clone our array. We could copy it. Remember, we saw that the array, if we set one array equal to another array, we just are setting the memory location that that variable name is pointing to. They're both still pointing to the same exact memory location. We'd have to actually copy the array to get it to have its own memory location. So we saw that with our Manatee app. I'm looking through here. There's a lot more information in the chapter. A lot of things that they're talking about are the things that we put in our sample code. So this is where we want some code. Let's put some of that in. Now, my new section here, I should have named arrays. I'm going to fix this. I need my tab to be named arrays. And my page up here, I'm going to name this notes instead of arrays. There it is. I zoomed in so far I couldn't find it. Let me zoom out a little bit so you can see everything. Move my notes around a little bit. And of course, with OneNote, that's one great thing if you want to change things up. It's almost easier to rearrange after you've got everything in there. Get everything set up the way you want it. So now it looks pretty manageable here. So I'm going to add a page for some sample code. Now, some sample code that I want to add, I have Visual Studio open, and one project that I have open is our Chapter 4A Array Practice project that we did. So I'm going to look at it real fast. The first thing that we did was a basic string array. So I could actually copy all of this code if I wanted to into my OneNote document. I'll get my print array and my main, maybe even my whole class. Now, if you don't have yours, that's okay, because you can do a screen snip of mine that's displaying on your Zoom session. Now you can, because I don't have anything selected, so it'll be a little easier to read. And paste it into your OneNote document if you don't have this project or you can't find it. Now I want to put this code in my OneNote page that I just created for sample code. And then I can do some things with it. I'll try my drawing, but like I said, it's pretty hard for me. I'm going to use these shapes because I think if I use the shapes, I might be able to get some of these arrows to be a little bit cooperative. Whoa. My arrow is pointing the wrong direction. There it goes. Okay, so I could change this arrow, make it a little bit thinner. Now, that would be pointing to my array declaration. And in our array declaration for this project, we also instantiated that array with those initial values. Now in our program here. We prompted the user for a name. We replaced the very first name in our array with the name that they typed in so that we could see how to assign a value inside an array. And then we swapped some values by using a temporary variable so that we could do some example swapping. So any sort of information that you want to put there is going to be helpful to you. Now in that same project, our array practice project, our average diff program prompted the user for input numbers, validated the numbers as numeric, then summed all the numbers up, calculating the difference between the average and this number. So if you want to copy that into your OneNote document, do that too. And then of course you could grab the PowerPoint from Canvas. We'll give you a couple minutes to copy those kinds of things in, and then we'll create a section for our exception handling. Well, actually, we have a few more things for arrays, don't we? I'm going to give you a couple minutes to get those in. Okay, in our arrays, I want to look at notes again and add a few more advanced things. So after our array class, in a back tab, and we have multi-dimensional arrays. So if we want to have a two-dimensional array, we would specify a comma within our square brackets. Now C# is row dominant. That means the first index is the row number. So anytime we're looking at a two-dimensional array, if I had some sort of matrix, my row number is always going to be specified first. And that could be different for different languages, different programming languages. But for C#, row number is first. Now, when we work with multidimensional arrays, you'll find that they get very complicated very quickly. So with object-oriented programming, we can usually use a class better, more effectively, I guess, than a multidimensional array. So that's why you don't see a huge amount of information about them or a lot of practicing with them, because we'll just use a class, and then we don't have to worry about that row column stuff and all that complicated information, because we just have a class that defines each row. And so we've already got it taken care of normally. Now, another thing that we can have then is jagged arrays. And these are two-dimensional arrays or more. So we can have three-dimensional and four-dimensional arrays, and the kinds of thinking that goes along with that, which is pretty out there. Now, a jagged array is two-dimensional or higher, but the rows are not the same length. When I'm working with an array in C#, I know that my length is predefined. I can't change that. It's stuck. But I can have jagged arrays where the number of columns for each row is not necessarily the same. So again, that can get pretty interesting to work with, but it's totally possible. All right, anything else about arrays you can think of that you want to put in your notes? Got it all down? I think you got it all. Let's create a new tab for exception handling. And then this very first page I'm going to make will be our notes again. Sometimes when you're rushing around trying to get everything done, it's hard to stop and really focus on the material. But oftentimes if you just take a few minutes and really focus on getting it organized in your head, it really saves so much time in the long run. So what are exceptions? We have several types, actually. Let's talk about, first of all, let me zoom in. Zoom, not menu. So the first thing that I want to think about are bugs. Bugs are errors made by the programmer. And of course, we all know, right? Grace Hopper found the first bug. It was a roach. I've heard so many stories, but I think the most recent write-up say it was a roach. It was fried in the circuitry, right? And so it caused problems.
It was a literal bug.
Literal bug, yeah, it was a roach. And so Grace was, if you've heard the story, she worked for the Navy, or was a naval person, and invented the COBOL programming language. And in testing of something, I don't think it was COBOL, the roach had gotten into the circuitry and fried some stuff. So it was actually a circuit problem, not really a software problem. So, you know, we always get blamed for those hardware issues. It's been that way since the very beginning. But that's where the first bug came. It was really a hardware thing.
Where the term came from.
Yeah, those bugs get into the hardware and cause the software to malfunction. Okay, so but if we're talking about really bugs, we're talking about things that we should be able to fix.
We take the roach out.
Yeah, take the roach out. That would work. So these should be fixed. I don't know how else to say it. They should be fixed. Use the debugger. That's why we have the debugger. Now, a thing about bugs, you would not create bugs in your code intentionally. Not normally. Some people would. You know, we have all sorts of personality types. But intentionally, you would usually not. So that means bugs are very hard for you to find, right? Because, again, I might have said it to your class last week. I don't think so. If I did, I apologize. If you lose your keys, if you knew where the last place you had them was, they would not be lost, right? And where are you going to find them? In the last place you look. Because once you find them, you're going to stop looking. That's how bugs are. If you knew there was a bug, you wouldn't have made the bug. So it's going to be very hard for you to find. And once you find it, you'll be done, because then you'll have found it and it'll be all fixed. But don't worry, because it's not something that you did intentionally. And that's why sometimes your duck is really critical, because you can talk it out with your duck and say, I didn't do anything wrong. It's the computer, because I obviously did this correctly. And your duck will agree with you. It's the dumb computer. And then maybe you guys can figure it out eventually on your own together. All right, so what's different than a bug? A user error. We've all seen those. This is where the user caused the trouble. So it might be that they type in an invalid input. They type in a non-numeric piece of information. Obviously, we should handle that. But they could actually type in a bad code or something that we're not expecting. And so we could have some sort of problem because of that. Now, what do we do for this? This is usually a matter of user training. It could also be a software update. But one way or the other, we've got to get around these kinds of problems. Next are exceptions. These are the kinds of things that we just didn't know were going to happen. They say runtime anomalies. That's true. It's like the losing a network connection. That would be a big one, right? Because we're assuming that we have this network connection to read the database or read some file or do something, and all of a sudden we don't have access to it anymore. So our program is just pretty well toasted because there's nothing else that we can do. We could have a file that's been deleted that we're trying to read. So lots of different things that can cause exceptions for us. We could have a memory error, in the system. All of these things are exceptions. So these exceptions are things that are difficult for us to control. So those user errors, we might not be able to use those, control those users, but eventually we can get them under control and get them fixed. So we're going to be using .NET exception handling. Whenever we're using C# and .NET to handle our exceptions, there is a base class for exceptions, and it is called system.exception. Now, just like we saw, the array class allows us to use all of the methods and properties that are available to the system array class. The exception class allows us to use all of the properties and methods that are available to the exception class. So we can get to that exception message and all of those things that we need. So let's see, this thing, I'm using our new book to get the notes here, so it's a little bit less organized. So let's talk about a general exception. Now, a general exception is something that is thrown. You've seen it. You've been working with some application or some website, and something happens that it can't handle, and it gives you some sort of message to that effect. That's because an exception has been thrown. In the example we looked at for our car, the speed gets too high. So we throw an exception. If we were working on a payroll application, we might throw an exception if we were trying to increase an employee's salary and we couldn't find the employee. We might say, that's an exception. I just don't know what you want me to do, because by the time it reaches my code, we should have already found that employee. So missing employee on raise function, we have to throw an exception. Now, as we go through our program design with all of our design team and decide how our application is going to work, we're going to actually create a whole list of all of these general exceptions, things that we want to throw errors for, like missing an employee, a bad company name, something else that's not valid, all of the things that could cause us to throw an exception. Now, because of these general exceptions, we could have some that are application level. That's where we throw the exception. We can set the message, any of those kinds of things, error number, etc. So when we design our application, we're going to decide what all of our different error codes are, all our different error messages, so that we can have that all documented and all the programmers can access it. And then we're going to have a nice organized system, because no matter what kind of problem we run into, we all handle it in the same way. It's not going to be a big giant mess. Now we can also have system level exceptions. And these are exceptions that are thrown by the system. We can't control these, like file missing, things like that. Now, whenever we're working with exceptions, we catch the exception. Catching an exception. We can catch an exception that was thrown by our own application or by the system. We can display some sort of message. To inform. We can continue processing if we like. We'll have to recover all of our variables, set everything back to the way that we want it. When we use the catch keyword, we can specify the type of exception we want to catch. So for example, I could say catch IO exception. And that catch statement would only process exceptions that had to do with IO statements. Now we could also catch multiple exceptions. So I could have multiple catch statements. One that catches IO exceptions, one that catches divide by zero exceptions, one that catches non-numeric data exceptions, all of those things. We have a lot of code examples in the one that we put on TFS. So that application should give you a lot of samples of catching. We saw in our textbook, if you look through that, you'll see that there's some different data that you can gather from your exception class, really important things. And then we can have a finally block. Now the finally block is going to execute if there is an error. The catch executes. And it's also going to execute if there is not an error. So the finally will always execute. How's that? Now in your new book, in the textbook that you have, the C# Pro book, at the end of that chapter, they do give you a little bit of information about using the debugger. And I know that last week we talked about how important that chapter is, that it's actually a good one for you to read, because the book hasn't had as many good ones as we would like. But that one is pretty good. Now, if you want to add in your exception handling OneNote a page for sample code, you should be able to grab that TFS project that you loaded to TFS last week, the exception handling one, and pop it in here into your notes so that you have an example. I have time today, I wanted to revisit our audio CD project. We left off a while ago, so I posted it to our announcements in Canvas. Colleen, are you being able to get to TFS okay, or your employee thing messing you up? Or?
I tried it twice at home, and I was gonna just stick around today and see if I can.
Yeah, because you probably will have trouble being an employee. Yay.
But yeah, I figured as long as I can establish it, you know.
We'll see if we can.
Yeah.
Yeah. There's a gentleman in the other class who's an employee, works for the tech staff, and he was going to talk to him about it, but I haven't seen him since, so that's not a good sign.
Yeah, I really wish they just merged.
Oh, me too.
No,
They always make it so hard for you guys. It's like your punishment for being an employee. I don't know why, but that's why I didn't put it on the S drive.
They have like work study students too, and it's like, what did they do? You know?
It hurts every person I know. Okay, so that's why it's a zip file. We have employees take it to the S drive. It's just easier. So if you download that and extract it, or if you already had that project, either way is fine. But if you remember, we were working with audio CDs. I'm going to bring it up because it's been a little while. I had to kind of review myself. Now, in the one that I sent you, that zip file, we actually have two projects. We have our 3 audio CD and our 4 audio CD. Now, in our audio CD class, if you take a look at that, it should be the same for our 2 projects. We could refer to it in a better way if we kept it in its own project, right? But right now, we just have a complete copy of it. Has a lot of comments. Yay. Now, our first project has the user experience, which means it prompts the user for the input about the audio CD, like how many tracks it has and all that kind of stuff. When we get our user input, then we built our instance of a CD, we output the information about it and ask them if they wanted another. So it's a pretty nice application because we've got all of our user experience stuff in our main class, and then we have our audio CD class. Now, we decided that that didn't work very good, though, if we needed to just test a class quickly. So the 4 audio CD project has a tester. In our tester, we just said we're going to create an instance of an audio CD with these hard-coded values, and then we're going to print out the information about it. And that's it. So we saw it was a lot different than going through and asking the user for all that input, but it was a lot easier for us because we could just test our CD class that way and not have to worry too much about what all those prompts. Well, so now I'd like to create an array of audio CDs because I don't want to just have this one Brittany CD in our test class. I'd like more than that. So first of all, if I was going to do that, how would I do that? I'm going to open up a new line of code. I want this to be an array of audio CDs. So what would my data type be?
Straight. Going an array of audio CDs. Would just be an
audio CD. Right, I can actually use my audio CD class as my data type. So we'll make a list of CDs. And we'll say this is a new array of audio CD. And how many do we want? We'll say, let's say 5. It's not at me. I'm just going to say that I want to allocate this array. I really don't want to put entries in there right now. So let's instantiate that array. Just being mad at us, isn't it? Can you Google it? What can you do?
Don't you need to put brackets?
Do what?
You need to put brackets next to audio meter once you're
Up here? Oh, very good. So it wasn't even that same line of code, huh? Whoops. I just did something crazy. So we can use any class as our data type. And that's why object-oriented programming is so powerful. Because now instead of saying this is an int array or a string array, we can say this is an audio CD array. Now we only have 5 entries, but that's okay. What I want to do is go into some sort of loop. Let's create a CD here and fill this up. I'll be very, very ineffective here. CD3, we'll make it, I'm not going to put it in a loop as you can see. I'll go back to my Beatles albums. I think I'll create one more. Let's make CD4, and I'll make it 4, and let's see, who do we want it to be? I don't know any Rolling Stones albums. Song album. Let's put some numbers in here so we have something. And then I'm going to print out CD4. Okay, so that's 3 CDs. Now I want to add them to our array. So our array is list of CDs. I'll set up an integer named I, start with it at 0. I'm going to run this while I is less than 4 because I don't know if this is going to work right. I don't like it that way. I'm just going to mess with you guys. Let's try something instead. We're just going to say list of CDs, number 0 equals CD2. Now, as we put these CDs into our array here, notice some things. First of all, each of these CDs instances has its own name, right? I've got CD2 is an instance name. All right. Now, let's create another instance of a CD. For our third entry in our table, let's say it's a new audio CD. I'm going to copy this code here. And I'll make it 5. I'll make it some album here. All right. So in this case, I've created an instance of an audio CD to put into our array of audio CDs. But notice it's a new instance that is going into that array. It doesn't have a name outside of that array. The only way I could refer to this instance in the future is by referring to list of CD index value 3. And that's going to give me that CD. Right? So I don't have it in another way. It's anonymous. It is not a named instance. Now I want to go into a read loop, a for each loop, to print out those CDs. So I did the tab key. So IntelliSense dumped all this stuff in for me. The collection I want to use is list of CD. I want to call each of those a CD as I go through my for each loop. And I want to write them out. I think I'll go ahead and put a write line statement before that, entering for each loop. So whenever you're ready, you can try it, and you should see, what do we have? 1, 2, 3, 4 CDs print out from your for each loop. Oops, I've got to set my startup project to the 4 and try it again. So if I scroll up to the top, first, my output is as I created CDs. And then in my for each loop, went through my output again. So where's number 1? Number 1 printed out the first time I went through, but it didn't print out in my for each loop. Oh, it's this very first one, isn't it? Right here, we created a blank CD, this blank entry. So this is number 1. That's blank. So I could add it to my array. We called it my CD. And then when I run, it would be like out of order, right? Because it would be the last one. Questions about it? Can do that. All right, so if you look at your 3 audio CD project, let's go to our user experience there. And for the rest of your lab time, we have about 40 minutes. I'd like for you to work with the people around you on your table. So that means some of our groups are much smaller than others. So if you want to go to a smaller group, move over to these tables. Let's do that. Let's move some people. Let's. I'm not sure exactly which way to go with it, because we uneven number of 3s, but that should work out pretty good. So with your table, other than if I asked you to move around. Okay, so in our user experience here, we're prompting for input. We're building these CD examples. Your challenges with your table partner is to show me before you go how you could put each of these CD instances that we get from the user into an array of CDs and print out the array after the do while loop. So it should only be one line of code before the do loop to set up the array, right? One line of code in the do while loop to add the CD instance to the array, and then a for each loop after the do while loop to print it out. So let's see if you can get that done. When your table has it done, raise a hand or yell at me and let me know, and we'll take a look at it. So do work together, see if you can figure out how to get it going. A little more advanced than what we need for your unit exam, but it will make you feel more confident.